Hi there, I hope you are doing fine. This is Mr. Philip Kauma, the excellent biology tutor. I am answering a genetics question which came from a 2020 past paper for July in Yama GC Easy. Yeah, without wasting much of your time, let us begin. So red-green color blindness is a sex-linked characteristic. Red-green color blindness is a sex-linked characteristic. So red-green color blindness is one of the conditions. It's a condition where an individual cannot differentiate between red and green. If wakaona red, waona more green. Okay, it's a rare condition. Otherwise, simply a condition where an individual cannot differentiate between red and green. Okay. So question A, define sex-linked characteristic. Define sex-linked characteristic. The answer is, this is the appearance of a non-sex gene on a sex chromosome. The appearance of a non-sex gene on a sex chromosome. Or you can also say the occurrence of a non-sex gene on a sex chromosome. So if we're talking about sex chromosomes, these are the sex chromosomes. So X is a sex chromosome. So if you're looking at the genotype for a female, it is XX. Genotype for a male, it is XY. Okay. So these are chromosomes, sex chromosomes. Yeah. So the appearance of a non-sex gene on a sex chromosome is referred to as sex-linked characteristic. Okay. What can cause sex-linked genetic disorders like the red-green color blindness? What can cause this, to happen? So the answer is, when an abnormal gene appears on an X chromosome, that's when this will happen. That's when a sex-linked condition will take place. When an abnormal gene appears on an X chromosome, this is said to be X-linked. So what you need to understand is the appearance of a non-sex gene on a sex chromosome occurs on an X chromosome. So we've got X, okay? X, this is for a female. Then XY, this is for a male. What you need to know is that the focus here is on the X, okay? The X chromosome. That's where the focus is, the X chromosome. So if there is an appearance of a non-sex gene, meaning an abnormal gene, if there's an appearance of an abnormal gene on an X chromosome, okay, if there's an appearance of an abnormal gene on an X chromosome, then it will lead to what we call an X-linked condition, okay, or a sex-linked characteristic like red-green color blindness. So if there is an appearance of an abnormal gene on an X chromosome, it will lead to an X-linked condition. Okay, so this is what will cause, or that will bring about a sex-linked characteristic or a sex-linked genetic disorder if there's an appearance of a non-sex gene on an X chromosome. Yeah, and these are passed on. These are inherited characteristics. So if a parent has got an X chromosome which has got an abnormal gene, that abnormal gene can be passed over to the offspring. Yeah. Otherwise, when an abnormal gene appears on an X chromosome, this is said to be X-linked, and it causes sex-linked genetic disorders like the red-green color blindness. Okay, so if you haven't understood, likewise, comment your questions in the comment section. I'll get back to you. And then question C, a normal couple had a color-blind son. A normal couple had a color-blind son. Using the gene R for normal color vision and gene small letter r for color blindness, write down the genotypes of the father and mother. So if you look at this, they are saying that a normal couple, meaning both the woman and the man were normal, okay? But they had a son who was colorblind. Now, how is that possible? Both parents are normal, but yet the son is sick. How is that possible? Well, it's possible if the woman is a carrier. So a woman can be sick or a carrier. If she's a carrier, she's considered to be normal, but she has that abnormal gene. Okay, she is normal, but she is a carrier of that abnormal gene, which can cause red green color blindness. In this case, okay, so even if she is normal, she is a carrier, meaning she can pass it over to her offsprings, and her offsprings can be sick of the condition. So yeah, the man is normal, but the woman is a carrier. They are both normal. Like I said, a woman can be a carrier, but she is considered to be normal. Okay, so yeah, a normal couple had a colorblind son. Using the gene ARA for normal color vision and gene ARA for color blindness, write down the genotypes of the father and the mother. So we know that the father is normal, but the mother is what? A carrier. So what are the genotypes? So those are the genotypes. I remember teaching this. If you can watch my tutorial videos under genetics, specifically when we're looking at sex linkage, I even gave the genotypes for all the sex-linked conditions, hemophilia as well as red-green color blindness. So these genes or these genotypes, they are already given. Okay, they are already there. You don't even have to think. You need to know to say, oh, the genotype for carrier, it's this one. The genotype for sick female, it's this one. They're already there. Otherwise, these are the genotypes. For the father, that's the genotype. For the mother, that's the genotype. The mother is a carrier, okay? So that's the genotype. All right. Using a genetic diagram, show how the son could have been colorblind. Could have been colorblind. Using a genetic diagram, show how the son could have been colorblind. So whenever you're drawing a genetic, I'm sure by now you know how to draw a genetic diagram. So whenever you're drawing a genetic diagram, you first start by parent phenotype, then you go to parent genotype, then you go to gametes, then you go to offspring genotype, then offspring phenotype. So we've got normal father, okay, as the phenotype. The father is normal, okay, he's normal. Then the mother is a carrier. She's normal, but she's a carrier. Okay. So those are the phenotypes. And then parent genotype, that's the genotype for the father. The ones that we found in C, question C. Those are the ones you're going to use. Okay. So the genotype for the father, it's that one. The genotype for the mother, who is a carrier, it's that one. As you can see, X to the power capital letter R, X to the power small letter R. That's the genotype for the carrier. And then gametes, you just bring them down, you put them in these two circles to just create space for crossing. And then the crossing occurs, which is also known as fertilization. Okay, so they will cross, and then we're going to have those results. Offspring genotype, those are the genotypes as you can see. And then we've got offspring phenotype. So if you check the results under offspring phenotype, we've got normal male to support normal female, that's a normal female, and then we've got a carrier female, then we've got a normal male, and then we've got a sick male, and that's what we're interested in, the sick male. So this proves to us that these two individuals can actually have a son who is sick. So question D, we've answered. They said, using a genetic diagram, show how the son could have been colorblind. We've shown here. There's a son who is colorblind. There is a sick male. So it's possible that these two can actually have a sick offspring. All right, my excellent biology students. Those are the answers to this question which came in 2020, paper 2, July, Nziyama GCE. I hope you've enjoyed. Please like this video so that other students can have access, or so that it can be visible to other viewers. And then also subscribe to my YouTube channel. I am going to really appreciate. This has been Mr. Philip Koma, the excellent biology tutor. Stay blessed.